So he's just going to search for GEA customer, and we can go through them all, right? And then we're going to go jobs. And it's going to allow us to go through these jobs. And it's going to tell you whether it's a 3D program.
These are all the programs
graphic
for each part that we do.
So every part has the part number and the rev. They're going to match the part number, the rev, make sure it matches the drawing. If there's any rev changes, they're going to stop. They're going to see what changed. Does it affect them? Sometimes it's just a hole that changed, so it doesn't affect the forming. So they're just going to carry on with their job. But yeah, graphic, you know, we got different ones where you'll see graphics, and then they'll go 3D programs. So all these graphic ones, you know, there's a 3D, so same thing. If I get into that, I can edit. All right, so it's going to show you the part, but the guys are going to go into the tools. It takes a little bit to kind of get through it. I can go position, it tells you what tools, so what die we're using, what punch we're using, are we using any extensions or holders, all right? And then we can go into our position. It's going to show us exactly where to put the tools, right? All of our tools are in millimeters, so we've got this button here which allows us to convert our inches to millimeters, because we run everything on inches, right? So, and it's going to tell them what their tool links are, where to put them. Once they get those in there, we'll clamp our tools into position. Come on. And then they're going to come back into their program, and then we can paste down to the program, and it's going to show you how to put the part in. You can see the bend slowly bending, right? It's going to show your views so that the guy knows how to put the part in, right? What each bend is, and it works pretty good. But all these targets are all predetermined by our engineers. So when they send it down, the operator, he's just going to double check, make sure based on the bend allowance, being how much the material stretches when you form it, as to are all their targets where they need to be to achieve specific ODs. And we're forming within a couple of thou, right? Repeatability is awesome, very accurate machines. But yeah, they work out really good. So that would be, you know, like that 3D program, 8 bends. So now we could say get out of this. If the guy had to make a program, they're just going to come down to a new job. We all use like either drawing or angle, right? Position mode, every now and then. Position mode is going to be very cautious. You could break tooling if you're not careful, right? Because you're jogging. You need to know what all your dimensions are, or you'll start clashing tools together, and then that safety comes in, right? So we got to be real careful. But when we go into drawing mode, operator's going to tell it, you know, what kind of material he's using. He's going to put in his material thickness, the length and width of his part, right? So if I just left that all where it was, saying I'm going to go next, now you can draw a part out. Say I wanted to bend something like that, right? Then I can go next. It's going to ask me what kind of outside dimensions am I looking for. Well, if I want 2-inch dimension there, what's my angle? Is it 90 degrees? Is it 80 degrees? You know, am I going to do 120 degrees? Whatever the bend is, right? And then you just go through them all. Pick your angles, pick your sizes. That could be 3 inches, that could be a 90 degrees, right? And you got outside or inside. I'm trying to keep everybody going with outside. Some guys get confused with the inside, because then that changes your bend allowance, right? Or like your ODs, right? And then we can choose next. Do you want another profile being, you know, say it's going to give you one profile if you're bending one way, but if you got another bend going the other way, you can draw that second one out if you wanted to, right? So if we're only bending one way, it's just going to give us an idea of it, right? Show us what our part is. Now it's going to ask us for our tooling, right? So that was what, 135 material thickness it was looking for. We have our bend allowance charts that tells us for steel, for stainless, for aluminum, material thickness, and then what the bend allowance is. So that bend allowance is at 90 degrees. So it's going to tell the operator, I'm going to stretch, you know, let's say for 135, he's got 2 choices. So your inside radius, are we using an 0.32 radius, or are we using a 1/8 radius, right? And then they can follow that down and determine what the bottom die size is, right? But how much it's going to stretch. So we can use that information and we can put that in here. So 135, they're looking for, you know, say if we went with this one, 275 is how much it's going to stretch, right? They want a 1/8 radius and a 1 1/4 bottom. So they're going to come to their tools. They're going to look for a 1 1/4 bottom, which I think is L9. Oh no, this is a punch. So say a Wilson. VIU. So these are going to be like all of our punches, and it'll show us the details of all of our punches.
We're using wheel of tooling too?
Oh yeah.
Yeah, we have the same.
Yeah, so our BIU 024 is our 1/8 radius, right? So I could select, you know, our L9 die, which is going to be a 1, I think it's a 1 1/4, right? And then we can put in our punch, and then I can go no ram extension, right? Because it's asking for holders and stuff, right? So ram extensions and holders. If we're not using them, then we just enter through them. How many tool sets do you want to add? Right? If we're only running 1 tool set or 2 or 3, sometimes we'll have 8 tool sets in the machine, right? But we'll say no. It's going to throw in a full bed of tools, and then we can determine, you know, I only want 8-inch tool set, right? And if I'm going to put them at, say, 50 inches into the machine, right? And it's going to center them on, I can go next. The machine's going to center my part on the center of that tooling, and then I get to choose my bend order, right? The operator's going to stand here, back gauge is that side, so then I can sequence my parts. So if I'm going to do bend 1, we're not going to put the whole part inside the machine to form this, so I'm going to flip it so that majority of the part's outside, right? Then I can go to bend 2. Yeah, it looks pretty good, and I can go down to bend 3, and you can see it all. I'm happy, I don't see any conflicts with what we're going to do. Then we're going to go finish. It's going to jump straight into the program now. Tells you your corrections, you know, your X and your Y's, your R's, what all of these targets do. So Y top being where this is sitting right now for the ram, right? Y slow is going to be when we step on the pedal with a part in there, ram's going to free fall, and it's going to slow down, right? And that's going to be our Y slow. Our bending angle is going to be the target that we want. So once it bends that first bend, we take it out, we measure it, we see what we're getting. Say it measured 125 degrees. I'm going to come down here and I'm just going to say I got 125 degrees, not 120 degrees. It's going to correct it automatically, and it's going to hit it 5 degrees harder for us. We'll put the part back in. Yeah, you have to manually check it. Gotcha. All right, and then same thing, they're going to do that bend, and then they want to know, well, for our X target, is the dimension what we want? If it's 10, 15, 20 thou, an inch out, then we're going to come down here, say it's 10 thou small, then I'm just going to go plus 0.01. It's going to add 10 thou to that bend for me, right? Our R target is all just in the height that this back gauge sits at. So if I find that's too high or it's too low, I can minus whatever I want. You can see it drops, right? You can stop off the front of the tool, you can stop off of that portion, or you can stop off the posts on the back, depending on how far back your back gauges are going. Really handy. If guys make a mistake when they make a correction, we can just hit undo. It'll take away the last correction that we made, right? Which works really good. Z1 and Z2, that is going to be our stops, where they sit this way, right? So if we don't like where the program puts the stops for us, we just tell it, no, I want the stop here, I want the stop there. It works really good. Now, crowning is going to be this little motor that's on the side, and the crowning takes the center of our bed and it's going to push the center of the bed up. So if you're forming long parts without crowning, you might shove it in there, step on the pedal, you're going to pull it out, you're going to be looking at a banana.
Right.
Right. So the crowning allows us to push the center of that bed up to keep your bed nice and straight.
And it's all calculated.
Yeah, it's all calculated. The machine does it, but we can adjust that too if we want. So if it doesn't look good, we'll up the crowning on it to level the bed up. Right. And then we'll have our second page, tells us what kind of tonnage we want to run. You know, if the 4.2 tons isn't enough, we'll give it more tonnage. Right.
And is tonnage related to anything like speed or?
Not really.
Not really?
The higher the tonnage, it might take a bit more for the machine to push it, but these things are very accurate that they're going to push that tonnage to get to that target.
So if we push it at 5 tons or 50 tons, what's the difference?
Say, depending on what you're forming. Like, we'll have an issue where, like, say this program I made and I shove the part in there, step on the pedal. If it's not enough tonnage, it's going to kind of pinch the material. It's going to start to bend, but it's going to kind of like lag out. It's not going to want to bend. So we'll just ram up, pull the part out, we'll add 5-10 tons to it, put the part back in, then all of a sudden, boom, the machine forms it.
Okay, my question for you is, if this machine was able to figure it out, it needs 50 tons to bend the part, and you overrid it and did 75 tons, what does the machine see? Does it speed up, slow down?
No, it's just going to apply more tonnage to that bend, right? So the only fear that I see sometimes when guys are doing that is if you're, like I worry about crashing tools or something. Like our tools are set in here that, you know, we're allowed 50 tons per foot. So if the guys are going over that, it's going to come up here in yellow, giving you a tonnage overload, saying, you know, it's not going to stop the machine from running, but it's going to be a warning that you know, hey, watch out if you're not careful, you could damage yourself, you could damage the machine, you could damage tooling. 86-degree dies and shit like that, not bad, but when you're running acute dies and you're forming like a 30-degree bend, you got to really watch out because it's going to push that tonnage down into that die where your normal tonnage, it's going to stall out maybe, but you juice up that tonnage. If it goes over where it needs to, you're going to split that die wide open. We've had it happen. We don't like seeing it because our tools are very expensive, but it does happen. So usually if you're going to really increase tonnage, back your angles off. Okay. Right? It's easier to put a part back in there and bump it again than it is to have it go over, damage a bunch of stuff, and it's too late now. You can't. No. It still runs the same speed, yeah. So when you get really thick materials, sometimes it will go a little bit slower, sometimes, but we don't run really heavy material. But for the best part, these all run about the same speed. Yeah. So retract points are going to be a part of this retract here. So a retract point is, you know, like say you've got a part sitting on the stops like this one. Some bends that we do have internal flanges on them, and the part's actually going to go down. Well, you can't go down when it's sitting on the stop, so we'll put a retract in there. And the retract point is how much the machine, like the tooling, pinches before the stops move out of the way. Okay, so sometimes if the retract point's not set right, it'll come down, it'll kind of pinch your material for you. Stops will move, but if it's not pinched right, the part could move on you. And then it's going to start forming. You just screwed up that part, right? So the guy's got to be real careful about that. But then the retract here is we can have it retract 2 inches, 4 inches, 8 inches, just to get the stops out of the way. Slow return, we usually don't use these too much. Bend speeds are all just, we all default to 100. Some of the new controllers, we can run 200%. So we can actually speed them up so that the machine cycles faster, right? These two machines are old, we can't do that. We can run at 100%, that's it. Or if you have a big part, like say what these guys are forming, sometimes the speed of the machine is too fast. You can't keep up with it. So we'll slow it down to like 50%, so the part forms slower. So the guys actually have more control over that part. Flange length just tells you the length of that flange. All right, you know, flange width is going to be the width of your part in the machine. Back gauge motion comes in real handy. These guys are using their back gauge motion right now because these are dangerous. There's a big part inside the machine, and we think about that safety. We can't have the guys with their arms inside a machine supporting a part and have the stops come back into the next bend. We had it happen a couple of times years ago to where it was like everybody dropped everything, arms out of the machine, came screaming in, mangled the part inside the machine. So now we tell the guys to put delays on them. So when we go to back gauge motion, or if I go sideways, you can put delays on one bend, or you can put delays on all your bends. So we tell these guys when they're doing this, put delays on all your bends. They're gonna form through that one bend, the machine's not gonna move. They can pull the part out, you step on the pedal, then the stops move to the next bend. So very good for safety. You know, it gives the guys that opportunity. Sometimes those stops move so fast, you don't have time to get a part out of there, right? So it's just drop everything and everybody be safe. We can fix the part, we can make a new one if we have to, but you can't fix hands, fingers, and arms and stuff like that, right? So those are really cool in a sense. Now support here tells you like on one, right? Or you can change those off on one. Okay, some of them will automatically choose, but you can choose, I think it's stop, you're gonna be support, and then you're gonna be support one. It's gonna be that guy. Yeah, your flange width, part position is all based on your program is to the center of your tooling. So that's gonna be all the pages that we have here. Zoom, you can zoom into your bend so that you can see things better. If you need to, it zooms right out. Alt, you know, allows us to change some of our views. So I can change my punch, you can't see it on this one, but I can go punch rotation and it'll actually flip that punch. So when we're using, say, gooseneck tools that'll come out in one direction, we can actually rotate it the other way. So that helps. Same thing with the dies. Bend radiuses, guys don't mess around with too much with all these. That would be on that one. The finger, same thing. It doesn't always work, but the finger is going to be the finger stop. So ideally, you should be able to push that. This is automatically going to change to a different stop position. All right? It doesn't always work for us.
A lot of this is a lot of technical jargon here. But
John?
You can kind of understand, like, there's a walk more at your house,
Yeah.
right? So I don't know if that's open